We'll talk about some development tools and techniques around animating in React. Also, we will talk about some design patterns. But before I go ahead, I want to explain why am I talking about animation. I'm not an animator by trade, but I've always been very fascinated by animation. I really think that those clever little techniques that we use in animation can add an illusion to life into any medium that we are using it. And I think we should embrace animation in web too. And if you look at the design-forward website nowadays, you see that animation is actually a common feature. We have images and text fading in or appearing. You have sign-up blocks which are sliding in and out. There are a lot of animations happening already. But apart from animation being in fashion, it is actually an extremely powerful tool available for us as a designers and developer to increase the engagement with our users. But at the same time, animation can also present a challenge. If you overdo an animation or you inappropriately use an animation, it can be very distracting, or it can confuse your users. Like the slide here, it's pretty distracting. Like all of you are actually looking at the slides and listening to me. So animation can be very distracting as well. So every time, let's move on for this one. Every time we want to create an animation, we should have a clear purpose, and at the same time, a style that matches the brand. So like good design, good animations are also invisible. So one of the short way of actually creating an animation which is as functional, as attractive, is to actually look at the potential problem it can solve. So in the next brief section, we'll look at some typical problems that we can solve in web using animation. So let's look at the first one. When a user wants to know when the action is done. Feedback animations, like your depress button or your toggles or sliders, all of them are actually basically giving a direct feedback to a user's interaction. They are pretty much most commonly used animations nowadays. You see it everywhere. The other one is when the user wants to know when the action is in progress. So nowadays, when they interact with our digital product, they want to know what's going on at every step in the process. And you can use like pull to refresh indicators like this or preloaders to give them that information in an entertaining way. So it'll blunt the negative experience of actually waiting. The next one is, I want to know how long it'll take. Because a lot of time, it's not just enough that we are letting them know something is going on. You have to also let them know how long it's going to take. It is very frustrating without that information for a user to just wait indefinitely. So you can use an timeline animation like this one, or another progress bar or loading bar to convey that information as well. So that's a very helpful animation use. The next one is when I don't want to make my screen a mess. Well, if your page or a screen is a mess, overloaded with tons of information, it is very hard for user to look through all the information and then find the information that they need. So animation can help here as well. You can use something like this animation to actually interact a different data block with the user in a way so that it feels like everything is organized. The next one is, I want to see the key things first. Visual hierarchy and clear navigation are very important aspects for designers. So a lot of time designer wants to draw an eye of a user to a certain element first. Animation can be really helpful here as well, because all the elements that are animated, there are more chances that user will notice them first before any other elements. So that's definitely a very good use case. Then you want to feel like the interaction is natural. As I said, animation can add an illusion to life. And research shows that when users are interacting with your digital product, the more natural the interaction is, less cognitive load it is for users' mind to actually interact with it. So animation can help here as well. When you're asking a user to press a button or pull to refresh, you can actually use an animation to animate an element that is getting pressed or pull. In reality, nothing is happening, it's just a digital element, but you're making it feel like it's actually getting pressed, and it's a lot more natural for user to interact with that then. And the last one is when the page is simply boring and you want to add some wow factor to it. Obviously, animation can be of great help here. You can use an animation, decorative kind of animations, to create something ordinary into extraordinary. Or you can enforce a brand using this kind of animation. But in saying that, these kind of animation doesn't add any information. They're merely there for decorative purposes. So we should be very careful on this kind of number of animation that we have this kind of animation, like we can't overdo it. So we looked at some common design patterns where we can use animation in our day-to-day work. But identifying where we can use animation is only half the battle. In order to create a good animation, it takes the whole team. So it's as important to actually be able to communicate animation very clearly as well. So in the next brief section, we'll talk about how best to communicate or define an animation when we are talking about animation. Because as a developers, we need to ask the right questions when the brief is getting delivered to you. So when you are defining animation, there are 3 things you should consider asking. First one is trigger, obvious one. What triggers an animation? Is it on a page load? Is it on a button click? What happens when the animation starts? So that's an obvious one. The next one is action. What happens in during the animation? What moves, what fades away, what transition in and out. So that's your what of your animation. And the third one, which is probably most important, and we don't ask that many questions, is the qualities of animation. Qualities of animation actually defines how your animation is going to happen. And it's very important to know the qualities of animation to make animation very natural feeling and performant. So we look at a little bit further in the qualities of animation in the next one. So obviously, there are a lot of qualities out there you can talk about. But there are 3 main things that you should be asking at least. The first and most important is easing. Easing is a rate of change. Something changes over the time. So in your CSS term, these are your timing functions. So every browser understands 4 standard timing functions. Ease in, which is accelerate. Ease out, decelerate. Ease in, out, so accelerate first and decelerate later. And a linear, which is no rate of change. On top of these 4 standard, browser also understands the 5th one, which is cubic Bezier, which basically gives you a way to create a custom animation using mathematical formula. And you can go to websites like cubicbezier.com and play around different easing and see how your animation performs. So that's an easing, very important one. The next important bit is the duration, probably an obvious one. How long the animation lasts. Is it 1 second, it's 200 milliseconds, depends. And you have to be very careful on that as well. You need to play around with the different values to get the right result. Because if your animation is too fast, you won't even notice that it happened. If it's too slow, it will come into user's way of doing something, or it will annoy user more. So you need to get the right duration. And the third ones are properties. These are your CSS properties that are getting animated. So you need to ask what CSS properties are also getting animated, or discuss at least. Now, with the properties, not all the CSS properties are animatable, and the one which are animatable, not all of them are as performant on every browser. So we have to be also careful on what CSS properties you are animating it. And most of the time, the commonly used one and your most sure bet are opacity, position, scale, and rotation. The 3 of them that done through a transform. So these ones are actually most performant in most of the browsers. So that's something we have to be careful on. So we looked at identifying some design patterns where we can use animation, some ways to communicate animation and define. In the next section, let's get down to a nitty-gritty of actually developing an animation. So what are the tools and techniques available? Well, good problem to have. We have so many tools and techniques out there. It depends on what context you are using. You'll be a different library or different tool would be useful to you. So let's start looking at them first. What's available natively? So first and most obvious one is CSS. We all have used it at one point or another. CSS gives us a 3-way to animate: transition, animation, and request animation frame. And it's pretty much mostly commonly used, your go-to kind of tool every time. It's super performant on every browser. It's hardware accelerated. It's very easy to start. The only downside of CSS is as your animation gets complex, you have more than 3 sequences involved, it's really hard to do with CSS. You can't do like staggering, motion along the path, or chaining animations that easily in CSS. So that's a downside. The next native option is Canvas. Canvas allows us a way to do a visual space scripting, and in which you can create a complex interaction on drawings. And it's super powerful. Canvas ninjas out there on the web has done an amazing job. You can see there like lots and lots of playful things are happening with Canvas. So yes, it is powerful. The downside of Canvas is though it's not easy to make it responsive. So if you're making an animation, it has to be our website is responsive, probably Canvas is not going to be your first bet. And at the same time, it's not easy to make it accessible as well. So that's something to consider as well. The next one is WebGL. WebGL again is like super powerful. You can do amazing things with that. Awesome for 3D animations, awesome for AR, VR stuff as well, and it's very widely used as well. But underneath, it uses Canvas. So it has the same drawback of Canvas as it is normal. Plus, the learning curve is a little bit steep on that one as well. So let's look at what's available as an external libraries or third parties. Well, the first, most notable one is GreenSock, GSAP, TweenMax, TweenLight, all of those same name. GreenSock is kind of a de facto standard library for animating on web. So if you've considered any third-party library, you probably would have thought of GreenSock at one point. It's super powerful, extremely cross-browser functional, very performant, and it comes with so many plugins that with those plugins, you can actually animate anything. So the only downside of GreenSock, it's a third-party dependency on your application. Licensing is a little bit funny, and the plugins are usually not free. So you need to think about those things. The other one is Velocity.js, which comes as, for React, it's a Velocity React. Again, it's similar as GreenSock, except that it's a little bit less bells and whistles. Then we have React Motion, which is a new, but it's supremely powerful. It gives you like spring-based motion, like which you can use, like, create a game-like animation and all those things. Very powerful. The downside, its learning curve is a little bit steep, and at the same time, it's not very good for timeline-based animation. Good for interaction, like one thing starts another and second thing starts another, but not with the timeline-based animation. But there's a new one called React Twin, which is based on React Motion, but it's a lot less easier to use and also supports the timeline function. But it's a new kid in the block, so still working out the performance-wise, what's the pros and cons and everything is. On top of that, there are just so many libraries out there. Like there's a React CSS transition group, now called React Transition Group, gives you a lot of React-specific lifecycle hooks, specifically for animation. Then you can hook up your CSS animation to it. Then there's a Mo.js, Anime.js. So there's so many options out there. But as we have seen, all the options has either plus or minuses. You have something like natively available like CSS, super hardware accelerated way, but as soon as your animation gets dynamic, you can't use it. And on the other hand, you have GreenSock, which does everything, but it's a third-party dependency. So what's the deal? Well, W3C has been working on a spec or API for a while. It's called Web Animation API. The idea behind Web Animation API, or WAPI, is that we should be able to create a complex animation in native JavaScript without any third-party dependency at all. And it should be as easy to use as CSS and as hardware accelerated as CSS is. So idea behind this is once this is ready, this will be a one API to rule them all. So what's the deal here? Well, can we use it? So WAPI is relatively new. I would say relatively because the first spec came about in 2012. Sorry. First spec came about in 2012. And as you can see, the browsers are not easy to catch up. So you have Firefox and Chrome basically caught up, but Safari and IE are still catching up. So there's a long way to go. But the good news is WAPI actually comes with the comprehensive polyfill. And with that polyfill, we can actually start playing around or using it today. Why should we care about WAPI? Well, the thing is, when WAPI is available fully and all the browsers will catch up, these will be the most fastest and most performant way of actually creating an animation natively without resorting to something like WebGL. And WAPI is not just a replacement for CSS animation or a third-party library. It's actually a lot more. It can give you a lot of sophisticated functions, like you can play, pause, reverse animation like a video, or you can change the playback rate or speed of an animation halfway through based on interaction. So potential is enormous what you can do with the spec. So in the next brief section, I'll look at how we can create simple micro interactions with the basic APIs from WAPI. So we look at the few basic API that you can start playing around today. Now the spec is extremely huge, and there are so many constructors out there. But there are a few basic ones that should suffice for most of the micro interactions. The first and very notable one is like element.animate. So if you want to animate a single element, you can call an animate method on it, and you can pass two parameters. The first one is keyframes, and the second one is option. The keyframes are basically an array of an object defining your movement of your animation. So this is your basically CSS keyframes. And the second one is options. Options defines how your animation is going to happen. Minimum you have to pass is duration, but luckily you can pass a lot more. Example, you can pass iteration, how many times the animation is going to play. You can pass the direction. Is it going to play reverse order, alternate, or normal? You can pass the delay, how many seconds it should wait before the animation starts. You can pass fill, which is basically how it's going to retain the CSS properties after animation finished or before it finished. So there are a lot of options out there. You can play around and create really cool animations using this. So let's look at how it looks like in real life. So I have basically two divs here, and I'm trying to create something like a loading animation. So I have two divs, and in my component div mount, I'm basically getting those two divs by reference, and I'm calling an animate method on it. So ball1 animate, and I'm passing the keyframes for ball1, passing the keyframes for ball2. Keyframes would look like an array of all these CSS properties that I'm transforming. And the timing for ball has a duration. So it's a 2 seconds, fill both. So I want to retain the CSS properties before and after. Iteration, infinity. So it right now keeps rotating. And easing, which is linear. So I don't want it to change it. I just wanted to linearly apply the easing. And if you look at the timing for a ball, it's exactly the same, except the direction is reverse. So now it's actually another way around. So it's as simple as that to create something like this with WAPI element.animate. So that's one. So let's look at the next API. The next one is Keyframe Effect. Now Keyframe Effect is exactly the same as element.animate. It is used to animate a single element. The only difference is instead of calling .animate, you create new keyframe effect, and you pass the element that you want to animate as a first parameter. And then you pass keyframe, and then you pass options. This will create an instance of a keyframe effect. And that keyframe effect, then you create a new animation and pass that as a second line, and with the timeline that you want to play this animation on. So you can actually have a multiple timeline within the same page and animation playing on that different timelines. So far we haven't looked at any clear advantage of using WAPI over CSS. This is where the difference comes in. When you create a new animation, it actually creates an instance of a new animation player. And once you have that, you can store it in the variable like this. And later on, you can call all kinds of method on it, like play, pause, reverse. You can have like a callback method, like on finish, on cancel. And you can do different things based on the animation is finished or start. You can have a getter and setter on the different properties using animation. So you can change a playback rate. There are a lot of options out there. So let's look at an example on that one as well. So again, I have a ball here, and basically I'm just bouncing a ball. So I have one animation for one div, and I'm just giving the keyframe effect and option for that. So I've created a keyframe effect here. Once I have that effect, I'm then creating a new animation, passing that effect with the current timeline, and I'm storing the player into the state. And once I have a button here, I click on that button, it's pretty much stop and starts. So on a handle click of my button, basically I'm just getting the player from the state, and based on the current state of the play state, I'm either pausing it or playing it. So it's pretty simple. It's a very simple example of how you can actually play around with the animation player. Okay, so then there are a couple of other noteworthy constructors as well, which are not available on current polyfill. In order to use these advanced constructors, you need to have a next level of polyfill. But with that next level of polyfill, you can still start using it. The first one in that category is the group effect. Group effect is basically similar as keyframe effect. It just takes an array of other keyframe effect or other group effect. And you pass that group effect into an animation, new animation. And as you would have guessed, when the animation starts, it starts all this animation together as a group. So it's very handy a lot of time when you have multiple animation happening. And the next one is a sequence effect. Again, very simple, very similar to group effect. The only difference is it will group all of these animation and play them sequentially. And you have an option here for duration. So you can pass the duration and it will make them play sequentially with this much duration, delay in between. So that's a sequence effect. So these are very handy constructors available in a level 2 of the spec. So far we looked at we actually scratched the surface of what this WAPI new spec is going to be. And with that as well, with these kind of basic APIs as well, we can actually create a lot more useful animation. So in the next brief section, I will show you basically some of the real world like micro interaction I've tried to create it. So the first one is I have a feedback button here. So I'm clicking on it and it basically waits for loading bar, comes back and shows a success. It's pretty simple. So as you can see, there are 4 animations are happening here. Once you click the button on a handle click, the first animation is the buttons resizes, then you have a loading bar animation happening, button resizes back, and then you have success appearing. So that 4 animation, 4 keyframes. So I have it here, the handle click. So in the handle click, basically, I am using an on-finish callback here. So once I have the first effect, so I'm getting the element by reference first, calling the animate on it, and then once that effect is finished, on that, I'm starting a second one, which is bar, and I'm animating the bar. Then that finish, I'm getting the element again and animating that element because I want to resize it back. And then once on that, I just set the state and have the second animation, which is opacity, appearing the success. So that's pretty much very simple, but it can look very sophisticated. The next one is I have a toggle button here. So sometimes I want to show AM, PM or something like that, and you can have something like that. So again, few things happening here. When you click on this, the ball actually resizes and moves on that side. Background color changes. You have stars either appearing or clouds appearing and the other one going. So there are 4 animations happening here as well. The code, simple. Again, I don't need to use anything else. I'm just using element.animate. So I have a bubble, which basically animating it. Then you have a background animating. So this is my handle click button. I have defined 4 keyframes and the same timing for all. And I want all the animation this time to happen at the same time. I don't want to wait until one's finished. So I'm just using element.animate. So that's that. The next one is I have a master detail page. So you have a button here, and this is a master page. You click on it, and sometimes you can do something like rotate, and the detail page comes in. And you can do it here, and it goes back. So again, 2 animations are happening here. When you click the button, it rotates out or in based on the state. And then once that is finished, then you have this green button also rotates. So there are 2 animations happening here. So again, the code is pretty simple. On a handle click, based on the state of the home page, if it's a home page or a detail page, I'm going to animate the rotate in or rotate out the page. And once that is finished, I'm setting the state of whatever the page is shown, and then I'm animating the button. And the keyframe would be just simple as rotate. So it's very simple implementation of like having a master detail page. And the last one I have is like a loader again, something like you can use for airline website or something when they're waiting. So this is an example of an SVG animation. SVG is super powerful, and like if you can use another session for the whole thing. I just want to show here that you can actually animate an SVG the same way as you would have actually created and animated any DOM element. So here in my SVG, I have 3 paths, which basically going on the circle. So these 3 paths, I'm selecting them by reference here and applying the same animation, similar kind of animation using WAPI, same element.animate. So the code. So I have SVG here, but as you can see, I have 3 paths, and I'm getting them by reference, swirl1, swirl2, swirl3. And once I have them in my component did mount, I'm just calling an animate method. And I'm playing a different CSS property here, stroke dash offset and offset. These 2 properties actually give me the kind of look where it's actually getting drawn. So I play around with different options and then actually get the result that I wanted. But it's pretty much applying the CSS properties same way as you would have done it in any DOM element. You get the DOM element by reference and the same way. So with this SVG, it's super powerful. You can actually do a lot of things with this. So these were very simple examples of how you can actually start using WAPI or any other library and start getting the micro interactions happening. So WAPI, when fully matured, actually going to give us a lot of flexibility or ease of use how you create a complex animation in native JavaScript. I have actually given all the example here with using WAPI in React. But in saying that, the idea behind it is not what library you use or what tool you use. It's the idea that animation is a super powerful tool available to us, and we should be using it in a right context, and we can get great results with that. So with that, I will start to wrap up. These are few references that I have that I want to share. If you want to start looking at the WAPI, you can start with Mozilla developer documentation. They've actually got a very comprehensive details on everything. These are few people, Brian Bertels, Rachel Nabers, and Dan Wilson. They're basically part of a spec itself. And I have some other books and a couple of people that I like to follow. They're good for general like animation related articles, and they have books as well. So there are obviously a lot of tools and people to follow out there. So with that, I'll wrap up. Hopefully I've inspired some people to start animating if you're not already doing it. Thank you.